Okay, so let's start with this example, which is quite a lot. Okay, object released from rest into water after 30 seconds, blah blah blah. Given differential equation is this. Show that. Okay, this looks scary, but just do things slowly. Now the first part is this, and you were told that show that this. Okay, so let's try it sort of first. So we start with a dv vt. Sorry, that's a kinematics. dv over dt g minus 4v. And how do we proceed from here? How do we solve this differential equation? G is a constant, I think, told here. G is constant. My first instinct when I see this question is, can I split this? Can I separate it? Can I do it this way? Sorry, I'm losing my voice, huh? Wish I see these answers quite often. Can I do it this way? Cannot, because this is minus, you cannot go down there. Yeah, I see this a lot, which is quite sad. So I can't split it out, I can't separate them, so it means IF. Okay, so my instinct says, okay, this is IF. So how do I IF it? I try to bring here to that side. dv dt plus 4v equals to g. And then people start wondering, sir, this is v and t, sir. I have no idea this is not y and x, how we used to do, sir. That's normal. I got that a lot as well. Okay, let's say if this is dy dx. dy dx, okay? So your v is y. Your v is y. Here is y. Your t is x. No t. So, by looking at how we used to do, now, dy dx alone. Okay? And then over here, you can see my y. And over here, no y. Aha! We got past from that mental trap. And what about this? Constant. Not that scary anymore. Can I ask a question? How many of you have, before you go to sleep, you switch off the light and you quickly run to your bed? Why are you laughing? Do you want to know one secret? It's between you and me. I still do it. Oops, I tell that in the internet. Okay, so now we find IF. Means 4. Okay, D what here? D what here? Sorry, it's not F, it's T. Your dx is T. So it's dt here. Okay? You follow here. Integrate this one. E 40. Can I simplify further? I can't. And where should I put this thing? I multiply to which one? Second one before IF, before find IF. Alright. dv dt. So I'm going to write things first. 4v. Because there's many alphabets there. So E40. 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 Yeah, I like left, and suddenly right. Depends on my mood, I guess. There's nothing for me to simplify. So I go forward. What I get on the left? What do we get on the left? IF times Y, very good. So your IF is E40 times with Y. Is it okay? What's wrong with Y? Your Y is V. Whoopsie. Good, good. I'm testing you. I'm being honest. I'm telling you the truth. Okay, let's do the easy one first. This one come down. GE 40. D what here? Why not the X? X is T this time. Yeah, I think I should change this one as well. Integrate this one. And now we integrate, right? You integrating to the respect of what? dt is supposed to be dx by dx is dt. Okay, let's do the left side first. Left side easy. E40v, right side. G is a what? Constant or variable? Constant, so it doesn't disturb the calculation. GE40, differentiate E40 over 4 plus C. Okay, that's why integration need to be good for you to proceed. So now we reach here, you got around 5 marks, sort of. But we haven't yet the way they want it to be. We want V alone, yeah. So bring the E40 that side. No, I'm just wondering a bit. Yeah, let's go with this one first. This one bring to that side, right? Let's go with the E negative 40 first. You can do over, 1 over instead if you don't like the negative. Okay? 1 over E40. Okay, we got this far as we could. But now we need, obviously it's different from here. So we need to substitute. But with what value? What? 0. The right sentence is over here. Yes, you're right. Object is released from rest into the water. So when the time is 0, rest velocity means 0. So at here, t equals to 0, v equals to 0. And someone said, I can hear, physics. So now maths makes sense. There's the application of it. So we mathematicians, we carve ways for the world. And the physicist takes our work. It's a never-ending argument. So t equals to 0, v equals to 0. See, I always make these mistakes. 0, I always want to transfer there. E0, GE0. My handwriting, sir. Okay, what do we get from here? 0, 1, G over 4 plus C. So C is negative G over 4. So where should I transfer this? Into here. It's a lot of things to do. So V equals to E negative 4t G E 4t plus here negative G over 4 over 4. Let's make my 4 better. And you just need to simplify it out. You can see G over 4, G over 4. What can I do? I can factorize. Now just use your answer show as a guidance for you to get the answers. G over 4, and yes, we can make educated guess. This one times here, and this one times over here. We got what they want. 1 minus E negative 4t V. Alright, that's a good one. Good stretch at the back. Okay, so we shown. Yeah. Oh yeah. Okay, if you're my student, please write this one down in exam so I know that you are my students. If you're the YouTubers as well as YouTube, please write it down. Wish I did find someone who used my method, the long division method, when I was marking the paper. And I was like, oh, this guy watched my YouTube. Woo! But that guy made a careless mistake. He got it wrong anyway, so that's a bit sad. That's a bit sad. Okay. The next part. Find the velocity when t goes to infinity. When t goes to infinity. This is one of my favorite type of questions. Okay, so when t goes to infinity, right, t goes approaching infinity here, the correct way of writing down is, of course, when limit t approaching infinity, what will you get? Okay, we write it down this way. Don't worry, this time is we are not that particular with your limits. So when t goes to infinity, this is sufficient enough. E negative 4 times infinity. 4 infinity is infinity, but still negative infinity. Do you remember exponent graph? You remember E negative exponent graph? Okay, let's say you don't remember lah. Which most of you lah. Yang baru calculator. Thank you. Just write down E. It's still not perfect. E power of negative 1 blah 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 blah. Maybe 99999 is better. And let's press equal. What do we get? Boom, 0. So this thing here is equals to 0. This whole thing here, 0. Or basically just remember that E infinity is equals to infinity, E negative infinity equals to 0. I cannot help you if you don't remember that fact. Thank you. Yeah, sponsor of calculator of the day. Shy guy. So V is G over 4. Which I'm not mistaken, this is the free fall. Yes, and then someone said, Sir, we got here, this is the final answers. Should we write this one, sir? M as negative 1. What happens if we don't write this in exams? We lose our marks. Don't worry, this is maths exam, we just care until here. But of course, if you want to be kiasu, so that I know this is maths and physics, go ahead, man. Okay, the next part of the question is crazy. I don't think this ever come out again. Sketch the graph. I'll be honest, man, I cannot remember it right now. I don't think this is part of the syllabus anymore. If it is, then we are so dead. I think it goes something like this. This is not. Okay. The logic goes something like this. Class. This is quite interesting. We know. Okay, you are free falling. I mean, if you release an object and then you let it go. Okay, listen here. If not, don't ever complain and say to me that teachers never teach you maths in real life. This is the equation when you're free falling. Okay, after the air resistance and everything, this is what your free fall. They have calculated it for you. So when you start from rest and then you rest, right? What happened to the speed? Yeah, I'm not sure where it stops, so I restart it again. So you start from rest and then this black marker pen, the speed increase. So we can say that you start from rest and then it increase. Okay, it start from rest and it increase. The speed increase. It increase until it has a lot of air resistance. If let's say the building is very, very tall and you let it go, after a very long time, it will reach a terminal velocity. Yes, that's the right word. And then the speed we reach will be constant from here. This is when we said, what is the speed here? G over 4. Of course, you can go further. This is your velocity. This is your time. So that's why you can check Mythbusters what happened if you drop a shillings from the skyscraper and it hits someone on the ground with the person die. Or we just have a bad headache. If you drop an ant, A-N-T, and you let it go, what will it reach the speed? Please don't do it on the real case scenario. Yeah, we haven't yet finished. That's a stupid questions. Show that the distance traveled by the object in the first 5 seconds is about 19 over 16 g. How do you go this one? Okay, distance traveled by the object in the first 5 seconds is about that. I think this is v times t. Yeah, I see it. My goodness. Yeah, this one it's no longer in the syllabus. Object travel is v times t. I think we can skip this question and go to more practical questions. Okay? All right, thank you. Okay, next thing, chapter 6. Class. Just a few things, chapter 6. Number one, I'm not that good in chapter 6. I'm going to go very brief. No recording is allowed. Please study on your own. Sorry about that. Thank you. Welcome. Right, oh, you got it. Yeah, dapat. Welcome. Really, you remember. Yeah. Everybody, I'm quite careful as well. You're working. Everybody careful. You got it. You got it. Right, you should be easy. Aeronautical. Okay.